Today we want to have a look at another proof on triangle. The proof we are having a look at today says the exterior angle of a triangle is equal to the sum of the opposite interior angles. Okay, let's have a look at this diagram. Excuse me. This is triangle ABC. This is an extension D. Inside the triangle, we have three interior angles, X, Y, and Z. Then we have another angle A, but outside the triangle, sharing the same point as Z, and they are sharing point C, as you can see. Now, we want to prove that this A, which is exterior because it's outside, is equal to the addition of these two, which are interior but opposite to this. So, how do we go about that? It's very simple. First, look at A and Z. Angle A plus angle Z. What will it give us if we add it together? 180 degrees. What is the reason? Sum of angles on a straight line, because A and Z, both of them are on this straight line. So sum of angles on the what? Straight line. Now, let's have a look at the three angles inside the triangle. Angle X plus angle Y plus angle Z will give us 180 degrees. What is the reason? The reason is that when we add all the three angles in a triangle together, it must be equal to 180. Sum of angles in a triangle. Now, since addition of angle X, angle Y, and angle Z gives us 180, and addition of angle A and angle Z also give us 180, that means it is not wrong if we say angle A plus angle Z equals to angle X plus angle Y plus angle Z. That is, this equals to this. Why? Both of them are equals to what? 180. Alright, don't forget that we are proving that angle A is equal to the sum of this angle. That means I will make this angle A the subject. So what do? I will bring this one to the other side. So angle A will be left here equals to angle X plus angle Y plus angle Z, then minus angle Z again, because when this plus angle Z comes here, it becomes minus. So angle Z minus angle Z will cancel each other. So what do we have left? Angle A equals to angle X plus angle what? Y, which is this. So this is our proof. That is about that. Now, I want us to share some knowledge on elementary angles in traversed parallel lines. You will understand what I mean by traversed parallel lines later. What are those angles that we can see in traversed parallel lines? We can find corresponding angles, we can find alternate angles, we can find vertically opposite angles. Now, how do we get all this from traversed parallel lines? Check this diagram I want to draw on the board. When you look at this sketch on the board, the diagram sketch on the board, these two lines are parallel. How do we know? Because they have one arrow, and the arrows are pointing the same direction. If there are two arrows there must be two arrows there also to show that they are parallel. When the number of arrows are not the same, they are not parallel. Or when there are no arrows at all, they are not parallel. Please take note of that. So the number of arrows must be the same and the direction must be the same. Okay. Now this other line, the third line, is the traversed line. That is, it cuts across these two parallel lines. So that is what I mean by traversed parallel lines. Okay, look at angle A. Position of angle A is between the traverse line and the first parallel line, but the angle A is standing above the parallel line. Can you see? It's standing above it here, above it. It's above this line, or the upper side of it. Then we'll come and look at this parallel line here, and also this same traverse line. If you look at B also, the position of B is similar to that of A, because it's also above this parallel line. It's between the upper side of the parallel line and the traverse line. This also is between the upper side of the parallel line and the traverse line. That means angle A is equal to what? Angle what? B. For what reason? Corresponding angles. Corresponding. They are corresponding. So corresponding means two or more different things that are at similar positions at different locations. Location of A and B are not the same, but their positions are similar. So that is corresponding. Okay? Now, let's have a look at alternate. Anytime you want to discuss alternate angles, you have to make out a Z shape. A Z shape. You know what I mean? Z shape. Yes. So, whenever you see a Z shape, that means this line and this line are parallel. And this is the traverse line. The angle at the corners are alternate angle, and they are always equal. Okay? They are always equal. See, let me sketch it out for you. This is parallel to this. This angle and this angle will be alternate. So that means from the diagram above now, I want to make out a Z shape. The Z shape can come in any form. See, 1, 2, 3. Can you see? 1, 2, 3. So that's a Z shape which is formed between these two parallel lines and these traverse lines. When I look at the corner of the Z, here and here, that means D and B are equal. For what reason? Angle B is equal to angle what? D. For what reason? Alternate. They are alternate angles. Okay? Now, finally, we want to talk about vertically opposite angles. Whenever we mention vertically opposite angle, it means there is a shape like X shape like this. Anytime you have two lines crossing each other forming X shape, then the angle on the opposite side are equal. These are vertically opposite. That means this equals to this. This also equals to here because they are vertically opposite. Now, let me now apply that. By the time you look here, you will see that angle A and angle D are vertically opposite because this is a cross. See, you can form a cross here. So A and D are vertically opposite. That means angle A is equal to angle what? D. What reason? Vertically opposite. That is vertically opposite angles. Also, angle B equals to angle C because this is another cross you can form. So, C. B equals to C. That means angle B is equal to angle C for the same reason. So, with this information, we'll be able to apply it to solve some problems later. Take note of that.